Okay, before we get into MIDI detail, I'll give you a quick run through of all the equipment here in this music room. I do spend some amount of time in here, but not enough. I should preface this discussion by saying I'm not a keyboard player. I'm just a keyboard collector and a historian of sorts. Heavily influenced by my childhood, where my best friend's dad worked for Krumar and a bunch of other music manufacturers. I went to a lot of NAMM shows. I'll put a clip of him playing when he was about 1/3 my age. Amazing, talented musician. But he kind of got me started on this business, gave me keyboard lessons for a little while, but really I'm just a bass player. That mini Moog is the prize of my collection. This is an original Model D from 1976. It was owned by a rock band called Blue Oyster Cult. I bought it directly from the lead singer, just as it just happened. I was on eBay and he lived, I don't know, 50 miles away. I drove up to see it and I pull up and I see this famous guy there. This Poly Ensemble, this Korg, is original. This is something like a, I don't know, 50 oscillator, has an oscillator per key, all analog, so that's pretty interesting. Speaking of analog, this Oberheim 4-voice in the corner, which I can't even get to right now, is also one of my favorite keyboards. I have a must-see video in the description that will give you just about the best introduction to synthesis and why this instrument's so important, done by a guy named Dave Spears out of the UK. This is a Dave Smith, the original Dave Smith Sequential Circuits Pro 1. The keyboard's kind of messed up, but it still works. And from here, I guess I'll switch over to the Oberheim OBX8, which is my newest keyboard. And we'll be spending some time talking about that when we get into the general MIDI section. This is, of course, the successor to the original OBX, which I happen to have one actually in various state of disrepair underneath there. And then the box on top of this OBX8 is an OBX clone called the CroBX. It's a 4-voice. That's a MIDI module. Modern synth-wise, I've got this Moog Matriarch. That's pretty new and modern. The Juno 106, which we'll talk about, is a 1984 keyboard. One of my favorite keyboards is the Roland D50. I don't have any room, money, or you know, ability to get that now, but Roland made this D05 quite a while ago, which is a MIDI module, and this is the D50. It's pretty amazing. I got a couple of drum machines, but these are just, again, the inexpensive clones that Roland released as reissues. I forget what they call them, but I think they're called reissues. I'll be using this one actually in one of the videos. The MSQ-100 is a hardware sequencer. What else? Moog Taurus pedals. That's the Taurus 3 actually. These are relatively new, maybe 10 years old. I've got the Minotaur, which is the small desktop version of that. I did some work for Moog a couple of years back, and they gave me this as a result. I helped with some beta testing, wrote some patches, and proof checked the documentation. This is my, speaking of Moog, this is my Moog Modular. So this is a Model 15 up to about there. This is a row of oscillators. These are the 901s out of Germany, with some other modules from France, the sample and hold, the voltage controlled oscillator, or LFO I should say. The envelope generators. This is a filter complement. It's the three two-space wide bank here. This is the normal low pass, the A, 904A. But again, these are clones. This is the B, which is the high pass filter, and this is the coupler, filter coupler. So let you do things like band pass, band reject, etc. And then a couple more of ECAs there. This is a sequencer, a bunch of sequencers, some control panel type, modules. This is a MIDI FITAR keybed in a really unassuming case with no pitch bend or mod wheel on it, and that's connected to this Waldorf Blofeld that we'll spend a little bit of time on. And then, of course, no modular is worth its weight, and they are heavy unless it has an oscilloscope. So this is my original Tektronix 465, which I bought from a guy named Dave Brown, who runs a really good Moog site, and he worked at Tektronix his entire career, and I bought that from him. They restore these things, which is amazing, and they sell them for like, $250, $300, plus shipping, of course. They're rather heavy. Up on top there, I have a couple autographed pictures of some people, and a bunch of pedals that I use sometimes. I have from an effects perspective, I've got an original Echoplex. This is a tape echo. This was actually restored by a guy named Mike Battle, who was the original guy that invented the Echoplex before he passed away. I used a Mac Pro, which is, early 2008. So it still works. I have a pair of UAD DSP cards in there with a bunch of effect plugins, and the monitor's way up here. And I think I covered everything in just, 5 minutes or less or so. Also, my favorite MIDI module, or my favorite MIDI accessory, is this MIDI timepiece by Moog, which lets you do all kinds of things to route MIDI, to echo MIDI, to block certain channels, to block certain messages, to route from one to another. You plug everything into it and into everything, and you do everything from the desktop, from the computer. And I think I covered it all. Oh, that up there is a BST, otherwise known as, who made the original one? I can't remember. But that's a tape delay. It's the tape delay that Eddie Van Halen used on Eruption at the end, that famous dive, which is based on them taking this. It's not a tremolo dive. It's them taking this famous delay. I think it was Echo. What was it? Echo tone? I forget. And they slowed the tape way down. I'm not using that. It doesn't even work anymore. But that's about it. We will be spending time on the General MIDI device that I have, the one and only, which is this Roland JV. You can barely see it through the rack. The JV 2080. It's got General MIDI in there. It's pretty decent. Has a good piano sound. So we'll be talking about that. And I guess because I said bass is my instrument, I may as well tell you about my bass rig, such that it is. I've got this small barefaced, I think it's a 10-inch cabinet, a Mesa Engineering Walkabout, tube-based amp. It's a tube-based front stage, and a couple pedals down here. I'm not big on effects, but I have a couple things. So that's about it. Let's jump back into here, and I will we'll kind of walk through the first example. I've got 3 examples to share with you, and then a couple more things pertaining to General MIDI, just to kind of round out this video. So give me a moment, we'll get set up and be right back. Piece of music I just played used 2 pieces of equipment here. I used this analog synthesizer for the bass line, and then it used this very simple MIDI keyboard across a cable, very much like this, to this device here, which is really just simply a MIDI module. It's the Waldorf Blofeld, probably around 2010, 2005. It's a wavetable based. It's pretty nice. Has a variety of sounds, but really it doesn't do anything except sit there waiting for me to do something like press a key on a keyboard that's MIDI connected. And notice it has no key on its own. There's no way to play anything on this keyboard. There's no notes on, nothing like that. No gimmicks. It's just a synthesizer module. To communicate with it, I happen to be able to send voltages across this cable bit by bit in serial fashion to be received here in order at a certain baud rate such that it can understand it. But really I'm sending notes and note information that this thing understands and can interpret and play a sound that's pleasing. So to start with, I'll play something like an F note on command, and I'll release the key, which will send a, you got it, note off command. And those 2 notes are the basics, or the basis of MIDI. And if you watch the MIDI module here, upper left-hand corner, that LED, when I press the key in, flashes once. When I let go of the key, it flashes again. And all you're really transmitting is what, 1, 2, 3, 4 bytes in that. 4 bytes? 3 bytes, actually. There's a note on with some information such as how hard did I press the key, what's the key number that I pressed, and then when I released it, how quickly did I release the key, often not interpreted, and what key did I release. There's other information, for instance, in that patch you just heard, I pressed the key like this one, and that channel pressure information was also sent. But not all of every keyboard supports that. In fact, not every keyboard supports velocity. So I'll talk about just the basics here. There's note on, as I said, note off, which is the release, the fact that I press this note with a bit of heft versus lightly touching it, and the fact that once pressed and held, I can exert pressure to do things with the control information to alter the pitch in this case. And there's plenty more. Of course, the ability exists to change the patch number from organ number 2 to, I don't know, the shed sound. A little bit of echo in that. And this has, hundreds of sounds built into it that many of them do. Here, Wurlitzer. So anyway, that's the first example of what I wanted to demonstrate here, is just the basics of MIDI. I can go on and on about the protocol, the rate of the protocol, some of the challenges, the fact that it runs over USB, the fact that it runs over 1/8 inch, or rather 3.5 millimeter TRS cables at this point. But I just want to really walk through the basics of MIDI so we can get to the point where we're examining and hearing the differences of what General MIDI brought to the table. The MIDI specification, I may have mentioned it, was developed in 1983 by Dave Smith and others. It established the communication protocol, the byte protocol, the command structure, on what was valid, what each byte means, and this standard. Of course, it was expanded later on to MIDI 2, expanded to General MIDI, and we'll get to that in just a moment. Thus concludes example number 1. In this second example, we'll be using a Roland Juno 106 keyboard. This is an analog 6-voice, but it has digitally controlled oscillators. It's a single oscillator per voice with a sub-oscillator. Nice filter and some other features. But this was the first Roland, or at least the first or second Roland keyboard to feature MIDI. It was produced in 1984, right after MIDI specification released its 1.0 in 1983. You'll notice on the right side, it's got a pair of MIDI cables. There's an optional through, which I'm not using. The red cable goes out into a sequencer. The black cable returns the MIDI notes back in. This is recorded in a kind of a closed loop directly with this Roland MSQ-100 sequencer. This keyboard does not have touch sensitivity. So there's no note velocity. When I press a key on this keyboard, hard or soft, it's always the same amplitude. However, this sequencer can record and play back velocity. It's kind of weird that it came out at the same time, but this was a kind of a budget keyboard. I think this cost around $1,800 when it was first released. There's a dip switch on the back of the MSQ-100 to configure it, to tell it to record velocity and other kind of CC MIDI signals, or to just record note on, note off. If you record only note on, note off, and obviously timing, it'll record approximately 6,100 notes. If you record velocity, it'll record less than that. The other quick feature about this from a MIDI perspective is this pitch bend wheel, bender as they call it, is a kind of a stick. This was Roland's trademark. It also affects vibrato if you push up, and configure some amount of low frequency oscillation on the oscillators. That will be recorded as well, assuming the dip switch is up. I don't have the dip switch up. I'm gonna record something very basic, just to show you, then we'll move on. There's a third cable in here. You can barely see it. This is a right angle. This is the through port on the sequencer. I mentioned that these in and outs are tied to these in and outs. This through is configured based on yet another dip switch to also send out. And this goes to a drum machine, this TR-09 Actually, I have it connected right now to the TR-09, which is a successor to the TR-08, you could say. But this is based on the Roland TR-909 drum machine, while this is based on the legendary Roland TR-808 drum machine. So this is an actual TR-909 is going to cost you several $1,000s in good condition these days. This was the reissue that Roland came out with about a year or 2 or 3 years ago. It may have cost $250. It's inexpensive, sounds okay, runs on a 9-volt battery if you like, has a little tiny speaker if you want to play it on the bus and all your friends. But in any case, I have it synced so that when I press play on this, after the count-in, when I press play, it'll say start to this drum machine, and the sync or the timing of this based on this tempo knob will be will trigger a number of MIDI clock ticks to be sent to the drum machine in time. You'll notice that this tempo display here is just dashes. Different reason why this is dashes. This is dashes because it's been sitting around for a while. It's actually set to that. If I try and modify the tempo here, I get nothing, just a little dot. That's because it's really dictated by the tempo here. So without further delay, I'm going to quickly start this thing. I only have one hand, I'm holding the camera. I'm going to try and play a quick sequence. It'll be about 5 measures or 4 measures. It'll end the 5th measure. And I have a foot switch I'm going to try and stomp on to stop it on time so we can loop it afterwards. Here we go. You'll hear the count in clicks, and then you hear the drum machine kick on. Okay. You may have noticed an echo. The echo is courtesy of this Moog Matriarch down here. I'm just basically using the Bucket Brigade delay that's built into this. The Juno does not have a delay. In fact, it's famous for its chorus, which I'm not using, but that's beside the point. This is a very simple patch, but I'm using the Moog for effect. So with that recorded now, notice it stopped at the 5th measure. The drum machine stopped automatically when I stepped on this foot switch down here. I'm going to press play. I press load to load or record. I'm going to press play. I'm going to press this button to repeat the play. This will loop 4 measures again and again and again and again. With that, I can play over it. Now keep in mind the mechanism here that starts this thing is this start switch. Sorry, this start switch. It will again send the start signal to the sequencer, so from the sequencer to the drum machine. It will again send the MIDI clock to keep it in time. And it will also play the notes back over the black cable into my Juno 106. If you notice what I was playing there, a period-specific piece from a particular movie played by a one-hit wonder, kind of a musician. I basically played a bunch of triads. Because this is a 6 voice, I've got 3 voices at my disposal, I can play something else. Because this is not a multi-timbral synthesizer, it all has to be in the same sound. And in fact, if I hit some of the same keys, it may have some weird effects. But I'm just going to push play and just noodle with something, and you'll get the idea in this example. And so we'll do it now. I have to reset it, sorry. There's a loop, back to 1. That's enough. That song is the second biggest synth sin. The first biggest synth sin I will demonstrate when we get to the Oberheim in the corner of my room here. So this concludes example number 2. Welcome to part 3, or at least example 3 of MIDI introduction, getting more advanced and working towards General MIDI. What I just played for you was just a quick improvisation on this Oberheim OB X8 keyboard. This keyboard is only about a year old. It's the newest synth I have in one of my favorite synths of all time, or at least it's based on it. In 1980 or so, Tom Oberheim released the OBX, which was up to an 8-voice synthesizer. In 2022-23, Tom Oberheim and his buddy Dave Smith of Sequential Circuits and Dave Smith Instruments partnered and released this keyboard. It's got some tricks and some things that none of my other keyboards have, and I'll tell you what they are real quick, then we'll move on to some content about MIDI. To start with, it has a key split. So lower half of the keyboard can be a bass tone, for instance, and I'll hit lower. It'll tell me, oh, it's the Campfire Harp. Strange name, that's a built-in preset. The upper is set to X8 brass, which I've modified a bit. You can see here it says edited. Press lightly, very soft, a little harder. The original X8 brass sounds like this. Also good, but not good for, you know, fast playing. So the keyboard splits right at the 2-octave range, and then you have the 3 octaves upper range. Different patch on each one, which makes this a multi-timbral instrument. It has an arpeggiator as well, which when invoked and slaved to the drum machine, I'll use the clock from the drum machine here. Pretty handy, and it's fun to play with. But anyway, that's what this is all about. It's an analog synth. I love this thing. A lot of interesting features. It's really great to play live. The layout is specifically for playing live. Just about every knob, every feature is mapped to a knob or a button or a switch, so there's not a lot of menu diving that you need to go through. In fact, they use this tiny OLED display on this most modern synth. But let's talk about other types of control, and we'll start with the left-hand controller. On the prior example, we saw the Roland Juno 106, and it's a pitch bender. It's also used for modulation, and recall it was a stick that you can move right or left to increase or decrease the pitch of a note, or actually tie it to the filter if you like. The Oberheim synths are one of the only other kind of defector in that they adopt this paddle system. So it's a lever that goes up and down, and then it has a left-hand paddle is a vibrato, or tied to the LFO anyway. If you push it up, it does nothing. If somebody can figure out or tell me how to use it when we push it up, I'd be much appreciative, because I haven't figured it out myself. I'm going to now show you what is the ubiquitous left-hand controller, and this of course is the pitch and mod wheel. And we'll talk about how this works with MIDI in a second. But first I want to turn it sideways slightly, 40 degrees anyway, rotate it here, tilt it, and see that the pitch wheel has a center position, and typically they're tied with springs on both ends. So if you do a pitch bend dive down and you let go, it'll snap back to the center position. Push up as well, same routine. Oberheim's paddles work that way. Roland stick works that way. You won't see that on the oldest of the Moog products, being the Mini Moog, and I think the Opus 3 is that way as well. The mod wheel, on the other hand, and again, this is like probably 95% of the MIDI controllers out there. The mod wheel is not on a spring. Its normal position is in the downward position, which would be off, and it's maxes out in the upper position. You can set it any way you like to I guess achieve the desired effect and then play along with it. Now, if this was attached to a MIDI controller, and it will be, this is a project I'm working on, but if this was installed in a MIDI controller, the pitch bend would work identically as the other pitch bend mechanisms, in that there's a special MIDI command tied to pitch bend, which will send 14 bits of data across 2 bytes, kind of an LSB and an MSB, except it's only 7 bits per, with the center being, I believe, 2000 hex. The mod is not that fortunate, unfortunately, for them, the mod wheel folks. Mod is tied by MIDI standards to something called a control change parameter, and it's lumped in with a bunch of documented control change features, such as the foot pedal, the ability to turn portamento on or off, the volume, and these are all 7-bit values. We'll talk more about that in a bit, but I just wanted to mention that we featured pitch bend in the last example. Here, I mean, I've used modulation a little bit here and there, but it's really doesn't get its due. And in fact, tied to something like resonance or frequency across this range, which feels nice and smooth with the potentiometer inside of here, tied to this axis. You can see it back here maybe. There's a analog to digital converter that will convert this down to just 7 bits. So clearly the halfway position, you're talking about halfway through a 64 or 63, and you can even hear the clicking. I can't feel it, it's perfectly smooth. But in my mind, I can hear the clicking where these bytes don't quite give this analog synthesizer justice. Manufacturers got around that by choosing some of the undocumented MIDI CC addresses, namely, let's see if I remember this correctly, 3, 9, 14 and 15, 20 to 31, those are all not used. And some of the synth manufacturers have done things like tied their resonance to 2 bytes. Likewise, tie the modulation wheel to 2 bytes. They have the standard way, and then they have an MSB that they would tie to it as well to increase the resolution and have a kind of a better sound or more control for the player. But there's one we'll talk about in just a moment that has to do with program change and the ability to change the program or the patch. Without it, and this is again a control change parameter, without it you really have a choice of only 128 patches. This machine is a little different than the others that I've showed you. It's similar, I think, to the, I'm looking over my shoulder here, yeah, very similar to the Juno 106. The programmer section has 8 patches you can select by pressing one of the keys. I'll take this out of split mode and just do the single voice. It's an Oberheim sound. This is the stock sound, I believe. Yes. I'll pick, let's see, Whirly Gig. That's patch 8. Patch 1 is it's an Oberheim. The way that they get around having more than 8 is using these 2 knobs here. And again, each synth will have their own way of doing this. The Blofeld I showed you earlier has a strange system of categories, filters, etc. Here in Oberheim land, we've got pretty simply a bank of Oberheim famous synths. I think there's 5 of them. So I've got the OBX8, the OB8, OBXA, OBSX, and OBX. Those are the 5 synths in reverse chronological order. And then based on the synth you choose, it'll have groups that match the original preset groups. The OBX8, which is this synth, is on its own, of course, and what they opted for were a number of groups of 8 patches. But from a MIDI perspective, the 128 selectable patches is really just groups of 8. So if you're into octal, it'll mean a lot to you. Any mainframe developers out there mean a lot to you. But the idea is as you kind of go forward through each of these patches, you'll go up by 8 at a time. So on group 1, I get 1 to 8, otherwise known as 0 to 7. Group 2 is going to go from 8 to 16. So I can get up to many, and you can see the lights change as each patch is recalled. But you can get up to the high numbers of patches until you eventually reach 128. So that's the way that this particular machine works. However, they're actually sending program change values based on which button I pushed in and where this group number is set. So that's just a quick distinction. I also wanted to mention that what happens beyond this? What do I do with a Waldorf Blofeld that has 1,024 sounds in it? And the answer is there's yet another MIDI CC called bank select, and that would be CC0. So simply send a CC0 with, say, 1 rather than 0, and it'll push you up by an increment of 128. And now you can get to voice 129, 130, 131, etc., etc. So that's a couple things I wanted to share. Talk about the pitch and mod wheel, talk about program change, talk about some continuous controller features. I'm now going to step behind the camera here and get something set up for our general MIDI discussion, which we'll move into shortly. And we'll talk about the 128 voices of general MIDI. We'll talk about what it meant for the industry once the spec was defined, the general MIDI specification. and more importantly, what it meant for gamers and people with systems that have sound cards, sound card add-ons, etc. Bring kind of us kind of full circle to where we started this series, which was talking about the dream chip.